Bismillahirrahmanirrahim. Rabbi zidni ilma. The quieter you become, the more you are able to hear. Assalamu alaikum everyone. My name is Dr. Sadia Rafiq and I'm the Superintendent Professor Dr. Sarah Afzal. Today my topic of presentation is counting rules of probability for probability distribution and binomial distribution. Learning outcomes include the introduction to probability, fundamental counting rule, permutation rule, combination rule, probability distribution, and binomial distribution. Learning outcomes. At the end of this presentation, participants will be able to describe counting rules of probability and binomial distribution. Introduction. Probability. It is defined as the chance of an event occurring. It is a basis of inferential statistics. For example, predictors are based on probability and hypotheses are tested by using probability. A probability experiment is a chance process that leads to well-defined results. An outcome is the result of a single trial of a probability experiment. A trial means flipping a coin once or rolling a die once, or like when a coin is tossed, there are two possible outcomes, head or tail. Here we will exclude the possibility of coin landing on its edge. In the roll of a single die, there are 6 possible outcomes, 1, 2, 3, 4, 5, 6. In any experiment, a set of all possible outcomes is called the sample space. So the sample space is the set of all possible outcomes of a probability experiment. Talking about some various sample spaces, if we toss one coin, the sample space is of head and tail, and roll a dice has a sample space of 1, 2, 3, 4, 5, 6. Answer our true or false question is true and false, and toss 2 coins, head, tail, 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 head, tail, or tail, head. Counting rules. To determine the number of all possible outcomes for a sequence of events, their rules can be used: the fundamental counting rule, the permutation rule, or the combination rule. The fundamental counting rule is used to find the total number of outcomes in a sequence of events. So in a sequence of n events in which the first one has k1 possibilities and second event has k2 and third has k3 and so forth, the total number of possibilities of a sequence will be k1, k2, k3 and kn. Note in this case, and means to multiply. This is very important point to note. Here we multiply. For example, a coin is tossed and a die is rolled. Find the number of outcomes for a sequence of events. So solution could be, since the coin can land either heads up or tails up, and since the die can land only 1 or 6 numbers showing face up, they are 2 into 6. It means 2 multiplied by 6, 12 possibilities. A tree diagram can also be drawn from the sequence of events. You can see if I toss a coin, head and tail, then coin, it has further 6 and total 12 possibilities. A paint manufacturer wishes to manufacture several different paints. The category includes color red, blue, white, black, green, brown, yellow. Type is latex or oil, text is flat, semi-gloss or high gloss, and use is outdoor, indoor. How many different kinds of paint can be made if a person can select only one color, one type, one text, and one use? So the solution there, person can choose one color, one type, one texture, and one use. Since there are 7 color choices, 2 type choices, 3 texture choices, and 2 use choices, the total number of possibilities, when we multiply all of them, we have answer of 84. Factorial notations. These rules are factorial notations. The factorial notation uses the exclamation point. This is 5 exclamation points means 5 multiplied by 4 multiplied by 3, 2, and 1. And my 9 means we will count 9, 8, 7, 6, 5, 4, 3, 2, 1. When this exclamation point is there, we will multiply all these digits. To use the formula in the permutation and combination, where a special definition of 0 exclamation is needed, where 0 exclamation is equal to 1. So for any counting n exclamation, n minus 1, n minus 2, and so on, and 0 exclamation is equal to 1. Permutation rule. A permutation is an arrangement of n objects in a specific order. This point is important in the permutation rule. The objects are in a specific order. This rule is used to find the number of ways that R objects can be selected from the n subject. Permutation rule 1. The arrangement of n objects in a specific order using r objects at a time is called permutation of n objects taking r objects at a time. So it is written as n, p and r, and the formula is p and r with n exclamation, n minus r is exclamation. The notation p and r is used for permutation. So if example, if 6, 4 means what it means, as we know, and 6, and then 6 minus 4, exclamation, and then this by adding the values, and then 6, 5, 4, 3, 2, 1, and the common are divided, and then we will multiply all these, and the answer would be 360. Suppose a business owner has a chance of 5 locations in which to establish her business. She decides to rank each location according to a certain criteria, such as price of the store and the parking facilities. How many different ways can she rank the 5 locations? There are 5 exclamation, then we will multiply them. The answer is 120. Different possible ranks. The reason is that she has 5 choices for the first location, 4 choices for the second location, 3 choices for the third, and etc. According to permutation rule, 5 locations were taken and then arrangements in order. Hence, 5 into 5, and we will put values in it. The answer would be 120. Different ways. Second is, suppose the business owner in previous example wishes to rank only the top 3 or 5 locations. How many different ways can she rank them? So the solution is 3 locations were selected from 5 locations. And its total number is 5 and R is 3. Hence, after putting these values and dividing that, then now she would have 60. Permutation rule 2. The number of permutations of n objects when R1 objects are identical, R2 objects are identical, and RP objectives are identical. So putting all these values where R1, R2 to so on is equal to n. Letter permutation. How many permutation of the letter can be made from the word statistics? So in this statistic, there are 3 S, 3 T's, 2 Y's, 1 A and 1 C. And if by adding all the values in it, but after multiplication and division, we have 50,400 permutations that can be made from the word statistics. Third is combination rule. A selection of distinct objects with regard to order is called a combination. Combination rule is used to find the number of ways that R objects can be selected from N objects. Combinations are used when the order or arrangement is not important, as in the selecting process, whereas in permutation order is important and in combination rule order is not important. The number of combinations of R objects selected from an object is denoted by C and R and is given by the formula. You can see C for combination, N and R, N exclamation, N minus R, and again R exclamation. It's the formula. Now we see the example. How many combinations of 4 objects are taken 2 at a time? So as we know the formula of combination, we will put the values in it. And now you can see 4, 4 minus 2, is 4 exclamation this, and by putting their values, we will divide them, and then there was a 6 combinations of the objects. Again, another example, a bicycle shop owner has 12 mountain bicycle in the showroom. The owner wishes to select 5 of them to display a bicycle show. How many different ways can a group of 5 be selected? So by again putting the formula and the values, there are 792 different ways. If we summarize the counting rules, number 1 is fundamental counting rule. The number of ways a sequence of n events can occur if the first event can occur in k1 ways, the second event can occur in k2 ways. So it is its formula, k1, k2, k3, and so on. Permutation rule, the number of permutation of n objects taking r objects at a time, order is important, and it is formula p n r and n minus r. Whereas in the combination rule, the number of combinations of R objects taken from N objects, The order is not important and its formula is C n r n minus r n then r exclamation. Now moving towards the probability distribution. It is a listing of the probabilities of all the possible outcomes that could occur if the experiment was done. It can be described as a diagram, which is called a probability tree, a table, or a mathematical formula. Constructing a probability distribution. There are three steps. Step one is making a frequency distribution for the outcome of the variable. Second is find the probability of each outcome by dividing the frequency of the outcome by the sum of frequencies. And the third is if a graph is required, place the outcome on the x-axis and the probabilities on y-axis and draw vertical bars from each outcome and its corresponding probability. For example, present graphically the probability distribution of the sample space of tossing 3 coins. So there's number of heads and there's a probability 0, 1, 2, 3, 1 over 8, 3 over 8, 3 over 8 and 1 over 8. So the values of x assumes are located on the x-axis 0, 1, 2, 3 and the value of px are located on the y-axis. The graph is then shown. So by putting all the values there, the graph is then made. Types of probability distributions are discrete probability distribution and the continuous probability. Further, normal distribution is an example, and in discrete there is binomial distribution and there is Poisson distribution. Discrete distribution, random variables can take only limited number of values. We can derive probabilities corresponding to every possible value of the random variable. For example, number of heads in 2 tosses. In continuous distribution, random variable can take any value. We can derive the probability of the random variable x taking values in certain ranges because there are infinitively many values of x. So, for example, the height of the students in the class, there is a continuous distribution. Binomial distribution. What is binomial experiment? If an experiment satisfies the following condition, we call it as a binomial experiment. What are those? The experiment consists of a sequence of n smaller experiments called trials and is fixed before the experiment. Second, each trial has only 2 outcomes. We label them as 2 outcomes as success and failure. 3. Trials are independent of each other and the success probability is constant from trial to trial. Binomial distribution. The outcomes of a binomial experiment, the corresponding probabilities of these outcomes are called a binomial distribution. The word binomial literally means 2 numbers. A binomial distribution from a random variable x, known as binomial variate, is one in which there are only 2 possible outcomes, success and failure, for a finite number of trials. However, we define success and failure. The 2 events must be mutually exclusive and complementary. That is, they cannot occur at the same time. Mutually exclusive, and the sum of their probabilities is 100%, which is complementary. Features of binomial distribution. The number of trials is finite. The trials are independent of each other. The success probability P is constant for each trial, and each trial only one of the 2 possible results, either successes or failure. Notation of binomial distribution P, the symbol for the probability of success. PF is probability of failure. P small, the numerical probability of a success, and Q is the numerical probability of a failure. So PS is equal to P, small p. The symbol of probability of failure and success is equal to small p, and PF is 1 minus P is equal to Q. So N is the number of trials, X is the number of successes in N trial. Note that 0 lesser than X and lesser than N is X is equal to 1, 2, 3 and N. Is the number of successes in N trials. Binomial distribution formula. You can see this, where N is the number of trials or the biggest being sampled. X is the number of successives desired. P is the probability of getting a success in one trial, and Q is 1 minus P, the probability of getting a failure in one trial. Parameters of binomial distribution. The two parameters that describe binomial distribution are N, the number of individuals in the sample or the repetitions of a trial, and P, the true probability of a success for each individual or in each trial. Mean of binomial distribution is NP, variance is NPQ, where is NP is equal to 1 minus P. Example, a die is tossed 3 times. What are the probabilities? No 5 in turning up, 1 5 turning up, and 3 5 turning up. In this solution, the binomial distribution, because there are only two possible outcomes, we get a 5 or we don't. So n is 3 for each, but let x is the number of 5 appears. Here, x is 0, x is 1, and x is 3. And by x is 0, by adding all the values in it, we got the probability of this 0.578. And but if the x is 1, by putting the values, it is 0.34. And by x is 3, x is number of 5 appearing, the probability is 4.62. In the next example, we see the hospital records show the patient suffering from a certain disease, 5% die of it. What is the probability that of 6 randomly selected patients, 4 will recover? So in this scenario, the binomial distribution, because there are only two outcomes, the patient dies or doesn't. So let number who recovers. Where n is 6, x is 4, let p is 0.25. Success that they live is q is equal to 7.5, and if it is a value if they die. The probability that 4 will recover. So we will put all these values and the value answer would be 0.032. Now moving towards our next section, which is MCQ section. Question 1. A store has 6 TV graphic magazines and 8 New Times magazine on the counter. If 2 customers purchased a magazine, find the probability that one of each magazine was purchased. So find the probability. These are the different options. So these are sort of mathematical things, so we need to have a solution. So by adding the values, probability, TV graphic and news time, we know it is 6 into 1, 8 into 1. After adding 6 into 8 and 91, so when we multiply 48 over 91 at the probability. So 48 over 91 is the probability that one of each magazine was purchased out of the total combinations. Second question, there are 8 married couples in a tennis club. If 1 man and 1 woman are selected at random to plan the summer tournament, find the probability that they are married to each other. These are different probabilities. So solution is, since there are 8 ways to select the man and 8 ways to select the women, there are 8.8 or 64 ways to select 1 man and 1 woman. So since there are 8 married couples, the solution is 8 over 64, and when we will divide this, then the answer would be probability is 1 over 8. These are a little bit confusing because we need a pen pencil to solve all these MCQs. That's why I have solution of every MCQ. There are 4 blood types, A, B, AB, and O. Blood can also be RH and RH negative or positive. Finally, a blood donor can be classified as either male or female. How many different ways can a donor have his or her blood labeled? So these are the options. The solution is, since there are 4 possibilities of blood type, 2 possibilities of RH group, and 2 possibilities of the gender of the donor, there are 4.2.2. Or when we multiply them, the answer is 16. So different classification categories are shown. So in this case, 16 is the correct option. Next MCQ, the digits 0, 1, 2, 3, and 4 are to be used in a 4-digit ID card. How many different cards are possible if repetitions are permitted? These are the options given. And if we see the solution, there are 4 spaces to fill and 5 choices for each person. So after the multiplication, the answer is 625. So there are 625 different cards. if repetitions are allowed. Next question, in the old days, there was a probability of 0.8 of successes in any attempts to make a telephone call. This often depends on the importance of the phone making the call or the operator's curiosity. Calculate the probability of having 7 successes in 10 attempts. And these are the options. So if we see the probability of sex P is 0.8 and Q is -2. So success and failure. The X is success is getting through, probability of 7 successes in 10 attempts. So probability is P, X is equal to 7, and by adding the values, the value is 0.20. So the correct option is A. If there are 3 effective ways of treating a cancer patient, surgery, radiation, and chemotherapy, in how many different ways can a patient be treated with 2 different treatments if the order of the treatment is important? So what is this giving you a clue? The order is important in permutation. So we see the solution by adding all the values and the exclamation mark by multiplying it, the answer is 6, and these are the different combinations which will be there of the surgery, radiation, and chemotherapy. So the correct option is D. In the next question, in how many ways can a roster of 4 club officers be selected from 10 nominees so that the first one selected will be president, the second vice president, the third secretary, and the fourth treasurer? These are the different options given, and the solution is again by adding all the values and putting them in a formula of the permutation, we will add them. 10 means 9 multiplied by 8 by 7, 6, 4, 3, 2, 1. This figure will come, and after this 720, and we will divide them. The answer is 5040. So the option B is correct. Next question, assuming that of all persons 17 years and over, half the males and one-third of females are classified as presently smoking cigarettes, find the probability that in a randomly selected group of 10 males and 15 females. So again, the options are given, and the solution would be 10 males, 10 females, these male smokers half, and the female smokers is the one-third. So P is 4 of 10 smoke, the value is this, and P 6 of 15 smoke, the value is this. So 4 into 6, we multiply them, the answer would be 0.0366. Option D. In an experiment involving a toxic substance, the probability that a white mouse will be alive for 10 hours is 7 by 10, and the probability that a black mouse will be alive for 10 out of 10 hours is 9 out of 10. The probability of both mice to be alive at the end of 10 hours is. The options are given, and the solution is white mouse in 10 hours is 7 times 10, and black mouse is 9 of 10. It is given. So the probability of both will alive, we will put them on formula and we'll divide them. It is 63 by 100. So option A is correct. Last question. About 50% of all persons 3 years of age and older wear glasses or contact lenses. For a randomly selected group of 5 people, 3 of them wear glasses or contact lenses. Compute the probability. Again, the solution is 3 out of 5. And by putting them in the formula, the answer is 0.3125. Option A is the correct. So these are all mathematically weak solved questions. So I have to give the solutions of all these options. This is the key. These are the references. This is our YouTube link. Please kindly like, subscribe, and share. And thank you so much.
Thank you very much, Dr. Sadia. Very nice presentation, like always. And especially, you have given a very good solution to each MCQ. And I hope everybody will do a lot of hard work in solving all the probabilities, because it is very, very important in the context of community medicine, in preventive medicine, as well as in biostatistics. So the probabilities, how to calculate them and how to come to these solutions, that is very important. During the presentation, I would also like to really appreciate your commendable effort in putting a lot of examples. And your examples, they were so near to our daily life, that your presentation is very easy to understand. Only one thing that I must say, that is in one of the slide that is not very clear. I have shared it, the screenshot with you. Please replace it with another slide. The
Thank
second
you.
important thing is in one of the MCQ you have written about white and black rats. I think this MCQ can be replaced by the people who are passing in IMM and in FCPS, so that the passing rate can also be determined, and the probability of passing both examination in first attempt, that can be a better scenario. And the same formula would be applied, and the same probability would be calculated. Yeah, but that is more real to our daily lives.
Okay,
So
ma'am.
thank you
So,
very much. Very nice presentation. And
thank you.
Dr. Ambar and Dr. Sadia always set a very high standard for each and every student who is present in the class and who are going to present in our next classes. So please maintain this standard. Thank you
Thank you,
very much,
madam. Thank you
everyone.
so
Allah
much.
Hafiz.
Allah Hafiz.
Allah Hafiz.
Allah Hafiz.